Hello, I'm Fedor from Fluence Labs, and today I'm going to be talking about managing business continuity risk with decentralized RPCs. So in the previous talk, Alexander told us about how enterprises could sort of onboard with Web3 technologies, and I'm going to talk about the enterprises who already onboarded into Web3 and created their dApps, and how they can they manage their risks and their business continuity risks with decentralized RPCs. So yeah, let's start. So first of all, let's talk dApps. So what's a dApp? A dApp is basically a web app that uses blockchain at the backend, and it needs blockchain nodes to access their RPCs, to interact with the blockchain. How the businesses can access the RPCs. So first of all, they can self-host them, self-host the fault-tolerant nodes, and this can be difficult and time-consuming. Or they can use the centralized SaaS RPC providers like Infura, Alchemy, or QuickNode. And most of them go the second way. So the SaaS RPCs for dApps are basically very convenient. They are cost-effective, but they introduce different risks. They are centralized, and they start to be a single point of failure because, you depend on single RPC provider, and if it fails, your app basically is unfunctional. And there are also deplatforming risks because, those SaaS RPC providers are basically just regular companies, and they have their terms of services, and they can terminate your service, and just in case you violate some points in their terms of service agreements. And of course, there is significant trust component. So you're in trust. You rely on some third party to sort of manage this infrastructure for you. Also, there is a thing called, so those risks are associated with the centralized providers. So is there basically any way to manage those risks? Is there any way to sort of work with them? And those are not the only risks. There is also some regulatory risks. So as you know, there were recent events when SEC just chased the companies who issued dApps, and they inquired about their native token, and they tried to sort of make their tokens removed from the centralized exchanges. They wanted to call their token a security. So basically, if the app is sufficiently decentralized, if it's not reliant on some central third party, they actually can benefit, and they can protect them from those regulatory risks. So what can we do with the RPC centralization problem? Well, let's de-risk those RPCs. But how? What can we do about it? So first of all, in order to de-risk those SaaS RPCs, we can sort of try to work with what we have. We have those centralized RPCs providers, and we can sort of include our own quorum or failover solutions inside the dApp. Or we can use the centralized servers tooling and open permissions platforms. What decentralized tooling? What open permissions platforms? Okay, and so if we'll take a look at the first way, so basically it gives us a lot of control, but we have to handle all the quorum and failover solutions inside our app. We have to sort of create all that logic ourselves, and it can be really cumbersome, and it makes the dApp very coupled to this code, and we have lots of complexity to manage. But we can also use open permissionless platforms. It gives us a lot of control, and it just decouples that RPC endpoint thing from our app, and basically you can use it as a drop-in replacement, and you're safe from those risks. And there is a possibility to have a real decentralized backend for your app. So meet Fluence. Fluence is the decentralized serverless compute platform. So it's verifiable and trustless. It's unstoppable and censorship resistant. It's fault tolerant. And it's a compute platform, so it basically allows you to run your apps in decentralized cloud it replicates the cloud stack, and it allows you to build decentralized apps easily. So basically, if you need an analogy, it's a Filecoin in compute. So why Fluence? So it's basically a platform that allows you to create to lower your costs and create the backends for your dApps. So there is no controlling party. It's controlled by a DAO. No vendor lock-in. You can basically switch any provider that uses Fluence or provides compute through Fluence. It's secure. There is zero trust security. It's open source, and it doesn't require no identity, no KYC, so no one can cancel your dApp. But what about de-risking RPCs? So this is the thing we've created based on Fluence network. It's called FRPC. So basically, it's a decentralized infuser based on Fluence. It's a super convenient showcase of what is possible with Fluence. And it allows you to deploy simple self-hosted RPC based on Fluence and connect it to your dApp, configure RPC providers, and and basically run any quorum, load balancing, or RPC methods on top of it. And it's available on Fluence testnet right now. So you can scan this QR code and find the source code of this app. So basically, what it allows you to do. So you have your Web3 dApp front end, and you basically replace the centralized RPC endpoint with our self-hosted HTTP gateway. So it's very simple. It's just a very simple app that you can run on anywhere. And it uses Fluence decentralized network to access RPC endpoints, centralized RPC endpoints, and load balance and run quorum on them, so we can basically validate the output that you get from there before sending it to your dApp, right? And this is basically a big deal. So you do not modify your dApp in any way, and you just redirect it to a special self-hosted gateway or to a Fluence-hosted gateway, and basically you get real decentralization. You do not depend on any single RPC endpoint solution, and you just work with your dApp and get all the benefits. And it's really cost effective. So right now I'll show you a little demo of how it works. Okay. So let me show you. So we're going to be working with this FRPC substrate solution. Right. Just a sec. I'll set up the mirroring. Right. So we're gonna work with this FRPC substrate. So basically you can hack along with me if you want, or just see what I do. So we start with this code, and we clone the repo. So once we get into this repo, we can see what we have here. So basically, it's a small, really small, dApp that uses that gets the block number from very simple from the EVM RPC and gets the data from some transaction. So nothing too complex, just something to make sure that it can access the remote RPCs. And we have the Fluence app that can run. So first of all, we deploy the FRPC to the Fluence network. But first we have to build it. So Fluence uses WebAssembly as the way to sort of deploy the apps. So we have our own WASM engine called Marine. So we start from building the app. It compiles the code of the FRPC service and gets it ready for the deployment. So while it's compiling, are there any dApp owners here in this room? Yep, thank you. So so we have right now we have built the project, and we can right now deploy it to Fluence network. So with the Fluence deal deploy. So basically, what's a deal? Deal is a special object that appears on chain that allows our testnet to sort of see what code you want to put into the network, and our nodes of the testnet download it, install it on the necessary amount of machines. So as you can see, we can specify the amount of workers we deploy on the network. And we are deploying this to our testnet. So in order to deploy it, we need to sign the transaction. And once the transaction goes through, the code we just compiled will be deployed to our network, and we can start working with it. So as you can see, it was deployed. Now let's wait a couple minutes for it to be fully deployed into our network. By running FluenceDeal logs, we can see that we can query the nodes about the logs of this particular worker, particular app. It usually takes several minutes for all the workers to be deployed. Huh?
Maybe you have the more productions. Logs for
Options what? Sorry?
to take the logs
It just needs some time to sort of go through. Oh, okay, you see? So it just deployed the app on our backend. Okay. So now we can work with the demo. So the code is now deployed into Fluence network, and we can work with the app itself. So first of all, there is a gateway app that is available in this package, and we can start work with it. So what it does is creates the it creates the connection with the Fluence network. You can specify the RPC endpoints you want to work with. You can specify the relay you want to work with, and basically the amount of quorum nodes you want to run it against. Okay, so okay, so we have now started the middleware server for our app, and let's try to work with it and see how our app can interact with it. So right now we are running this simple application, and as you can see, it started replicating those RPC calls. It started to ask the infer endpoints about the details of the transaction, and it just got the current block number and the transaction details. And as you can see, the app itself doesn't know anything that it's run against decentralized serverless network, decentralized compute network. It's a simple drop-in replacement for your existing dApps. And we basically have solved the and remove the risks of centralized RPCs. Now you can run the quorum and the round robin against those RPC endpoints, and you can make sure that you are not dependent on a single RPC provider. You don't need to modify your dApp, and so basically we just get a solution for this problem. So what else can you do with Fluence platform and after you have implemented the decentralized RPC? So the first thing, you can utilize Fluence to create the backend for your app, a centralized backend. So you not only can deploy this simple FRPC app to Fluence, you can deploy any kind of app backend to it. So right now, Fluence supports Rust that it can be compiled to Wasm as a language, but we are going to introduce support for Python and JavaScript. So right now there is a testnet running, and you can access the testnet, and basically there is a way to run different small apps that are available in our example repository against it. So we are currently in a testnet stage. We are going to release to mainnet in Q4 this year. If there are any questions regarding this app, I can answer them right now. And after that, we can continue with the discussion of the Fluence stack.
Thank you. So what are the trade-offs of using or going through Fluence and the decentralized RPCs versus using one directly? Like, I understand like the benefits, but then like I guess in terms of perhaps I don't know, latency, throughput, these kind of things.
So regarding, thank you for the question, regarding the latency. So it's usually adds about 500 milliseconds of latency, but it depends on the algorithm that you use to sort of query those endpoints. So if you run a quorum against multiple endpoints, it will take more time. And if you do just a round robin, or you just query the first endpoint that actually answers you, then it's will be much faster, and you will be able to basically you will not be able to notice any latency issues with it. Okay. Okay, so any other questions? Okay, so yeah.
Yeah, I was wondering how cost competitive it is right now compared to Infura Alchemy to use Fluence for RPC endpoints, right? Because I assume that the cost is indexed on the value of the token for compute. So right now, how you say how much? So what's the cost of your solution? Using Alchemy, using your solution?
Thank you for the question. So first of all, regarding the costs, so right now we are targeting to be, in terms of cost for compute, we are targeting to be like maybe 3 to 4 times cheaper than AWS or GCP. So the cost of compute will be will be much cheaper than in traditional cloud solutions. And basically, the Alchemy, you still have to pay for the RPC endpoints, but Fluence will allow you to sort of skip implementing the round robin or quorum solutions in your app. And cost-wise, we are launching the network with the decentralized with Fluent's Lambda showcase, or basically we allow running Lambda functions and applications like FRPC on it, and you just pay for each execution, and it's a fraction of what you are paying if you are doing that on Amazon Lambda or GCP or any other platform. So there will be cost saving, but I cannot say about the exact price.
Do you have a calculator or something for compute, or is it in your plans to?
Thank you. So we are going to have the exact economics numbers closer to the mainnet release. Right now, you can test it for free with our testnet. So basically, it's well, right now, yeah, there is a possibility to do that. Yeah. So, but anyway. And the costs will actually depend on the compute provider, because we are going to implement the solution both for the developers and compute providers. So compute providers can contribute their unused CPUs and unused RAM capacity to our network, and the developers could sort of leverage that capacity for and the prices will be much cheaper than with the traditional cloud solutions. So. For the release, we're targeting for the those Lambda functions, stateless Lambda functions, but later we are also going to support like stateful apps. So that's that's what we are going to do. Thank you. Okay. Any other questions? Okay, so right now we can talk a little bit about how actually Fluence works. So as if you can see, there are like traditional cloud backends that use centralized APIs. So we use a set of decentralized services that can be choreographed into and stacked together without like central authority, but with the decentralized network. And basically, you can write decentralized backends for DAOs. You can write solutions that allow you to just move any kind of backend to this network. Okay, and I think so. Well, I'm done with this. To summarize, FRPC is just a showcase of what's possible with Fluence, and you can decentralize your whole backend by moving it into a decentralized permissionless network. And you can easily audit and share and reuse distributed algorithms that are created with Aqua. It's a language that we have created to sort of write those algorithms. And you can write, you can find all the developer documentation on fluence.dev site. So thank you. If there are any questions, please ask them, or you can just find information about Fluence on fluence.network site, on fluence.chat. There is Discord server, Telegram group, and our Twitter. Thank you.